Earth science students, here we go. Welcome back. We're coming back to Earth. We're going to study Earth and Earth science. What a radical idea. First thing, we're going to get to rocks and minerals. We're going to classify rocks and minerals, but let's get a little bit some other things out of the way. Some little things build up to it. Here we go. The spheres we talked about in the beginning. I want to make a couple things clear. Let's go back to this because we've got the biosphere, the geosphere, the hydrosphere, the atmosphere. What about the lithosphere? What about the asthenosphere? What about all these things? Okay, back in my day, there was the core, there was the mantle, there was the crust. The core was divided in half. The mantle was sometimes divided in half, and then there's the crust. I want to show you how all these things interact. And this is a good image, and so is the next one I'm going to show you. So this is not to scale. You've got the core, all right, in here in gray. You've got inner and outer core, solid, molten, very hot, very dense, fine. Now you've got the mantle. The mantle actually runs from here, look at this outside layer, from here all the way to here, just below the crust. Core, mantle, crust. That's it. Core, mantle, crust. So the mantle covers all of this out to here. So there is the inner mantle and the outer mantle. Okay? Or I'm sorry, some books call it lower and upper. This is inner and outer, and this is lower and upper. I don't know why they're not the same, but some books treat it that way. That's fine. The asthenosphere here. That's the first thing that gets a new name. This is an area of partially molten rock right below the lithosphere. The lithosphere includes the crust, which can be thin under the ocean or thick under a continent. And the lithosphere also includes the top layer of the mantle right here in this light gray. The asthenosphere is the next layer down of the mantle because this light gray, dark gray ocean, excuse me, not the ocean, but these are rigid. They're solid. The asthenosphere is partially molten. So this is mantle, this is crust. These two are in the lithosphere, and this is then the asthenosphere. All right? So all of this is in the mantle, here, 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 here. But this is the lithosphere. So the lithosphere crosses over between the crust and the mantle. It's got a little bit of both in it. All right, let's try this. Image is going to look a little bit the same. Core, inner and outer, mantle. Here you go. So the mantle runs all the way up to just below the crust. The lithosphere includes the crust and one layer a little bit down into the mantle, upper solid mantle. The asthenosphere is partially molten. This green line, that's where things actually move. That's where plate tectonics happens. These all float on this. That's what's going on. We'll talk about that much, much later, and we'll get into these details. But since we came back to Earth, we're talking about rocks, we're talking about layers. We need to get into some of that. All right, speaking of Earth, here we go. Latitude and longitude. Okay, I don't know why. Way back in middle school, whenever I heard this the first time, for me, latitude was flatitude. Latitudes are flat. They look like the equator, up above. They're circles stacked, and they measure flat layers above the earth, or not above the earth, discs that you stack on top. Latitude is that. When you look at it from the surface, from the outside of the earth, that's what latitude is. Okay? Latitude is all of these parallel lines going around and going around. But where does latitude come from? How do you find that? You put a line at the center, you draw straight out to where you want to be on the earth, and then you measure an angle. So when you say 30 degrees latitude, that's what 30 degrees comes from. But if you stood in the middle of the earth and you pointed up and then you spun all the way around, you would make a flat circle right there at that 30-degree mark all the way around. That's up 30, and you could point down 30, and you could point straight out, and you could make all these circles. If you pointed straight up, that's 90 degrees, and if you spun in a circle, you're just going to stay at the point, and that's the North Pole or the South Pole. So latitude is flatitude. Now, longitude, they are not parallel circles. See, the latitudes never cross. That circle, that circle, that circle, they never cross. The longitudes are great circles because they go all the way around. Every single one of them crosses here at the North Pole and the South Pole. If I start here and follow this red line up, I'm going to cross at the North Pole, go under, cross the South Pole, and come back. If I scoot over here to a different longitude, I'm going to go north, north, north. I'm going to cross at the North Pole, come down, cross the South Pole, and come back up. So they're different. It's like you put your finger here and here, and you drew a circle, and then you spin the earth, and you drew another circle, and you spin the earth, and you draw another circle. Those are longitude lines. They're great circles. Okay? So prime meridian, that's where it all starts. Okay? That is not the international date line and clocks. We can worry about all that later. This is 0. This is Greenwich Mean Time or Greenwich, England. Okay? However you want to think about it, where it came from in history. That's where the prime meridian is. And then you measure east and you measure west. Okay? That's it. Ways to map our Earth. Speaking of ways, there are other ways to look at this. So you could look at all, this is only latitudes. These are only latitudes. Here we go, this one. Sorry. Here are your only longitudes. Then now you see how they all meet at the North Pole. They cross. Here you could see coordinates. You would measure north, because you would give the latitude first, and then you measure around longitude. That's it. All right. Other types of maps. Other types of maps we use that are really important. One of the most important, one of the most interesting, and maybe one of the most underrated are topographical maps. Topographical maps look old, frankly. They've got all these extra weird lines. Now, some of them are now done by shading and coloring, but in the old days, it was circle, 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 and weird squiggles and lines. Topographical maps show elevation. Okay, so we're going to look at a couple here. First of all, let me zoom out a little, and you can see, there you go, these squiggles right here. There's a number 500 right there, 500 right there. So anywhere along that line, it's 500 foot above sea level. If you go to the next line, it's higher. If you go the other way, it's lower. That's all these lines are. Why I pulled up this map in this region right here, the common joke is if you're driving south along I-55, once you cross the Benton Hill right here, it's flat all the way to the Gulf Coast. It's only sort of a joke. We live in an interesting spot because it gets really, really flat down there. And if we zoom out a little bit, one more, you can actually look at the shading. A couple more. You can actually look at the shading and see that right here, your Ozarks, the foothills start over here. And from here, there's a little bitty spot, but this is all low, low, low river delta land. Other things you can notice from this. See all that shading right there? Why does the Mississippi River flood into the Illinois side of the bank and not the Cape side? Look here. Look at the elevation on this side of the river versus this side of the river over here. This is completely flat. Move up. Move north here. Look at the difference in elevation in this part of Missouri and this, the floodplain over here in Illinois, before you get back to greater elevation. Topographical maps show you that, and they show you that really fast. There you go. Now you can see where the river is, but where the river is going to flood. And you could see that. So you see all this shading from Cape right through here along the Castor and then on down here to Wapapello. There's a little bit here. There's one set of plains right here. The Scott County Hills here. You can see that little spot. After that, there's nothing. It's really, really flat, kind of all the way down through this floodplain to the Gulf. All right, here it is, older set of maps, different colorations. You can see we're zoomed in. There's Benton there. There's the river. All right, here is Cape. Here is the first ridge. You've got a little bit right here that extends further south. But as you move this north, there is nothing. So this is I-55 running straight shot south right there. And then you notice that it's just flat all the way south. There's a better view, in fact. I don't know, I wish it wasn't, just didn't shade it red here like this is. But you could see all of that region, that there's a big spot. You could see the river plain. There it is. All right. That's enough time on topographical maps. One more kind. This is the kind I'm the least familiar with, but it's really, really interesting. This is a geological map. It's really interesting because first of all, it's pretty colors. Pretty colors. It shows you minerals. It shows you rock types and rock formations. What's underground? Maybe oil and gas. Maybe who knows? So this breaks it down by county, and it shows you all sorts of different data points. So here, you can even see that floodplain right there, and that dividing line just south of Cape there. And you can see different chemical compositions. See there, it's white. You can see floodplain of the Missouri River coming across where the Mississippi and the Missouri meet at St. Louis. You can see all sorts of stuff. Hey, who's heard of Ironton and Iron County? And do you see all those different colors over there? If I zoom back out one. This is acting really slow today. I'm sorry about that. But this is the U.S. Geological Survey. You can get all sorts of stuff here. It is not responding, and it's responding very, very slowly. So if you go west of Farmington, you go to Ironton, and you go to Iron County, there's lead mines, there's all sorts of stuff over there, and that kind of shows you where some of those different minerals are. We could zoom in maybe a little bit. I don't have a key on this map, so I couldn't necessarily tell you what the different colors and shading were. Now you're at an actual map and a grid where you could bring this up and you could look at what's going on. Okay. We have talked about different kinds of maps, the spheres of the earth, but it's now time to get into minerals. Minerals are what we're looking for. Minerals are what we want to talk about. Minerals and rocks and what makes all this stuff. But we got to learn what makes all this stuff first. So what we have is the periodic table. The periodic table when this loads. Here we go. Protons, neutrons, electrons. You've all had this before. I know you have. Freshman physical science. That's fine. Protons determine the element. Protons are the most massive. They're positively charged. Neutrons are almost exactly the same mass as a proton. They're super, super close, no charge. Electrons are negatively charged and they're tiny, like 1,000th the mass of a proton. Proton determines element. Electron determines how it interacts with other elements, how it bonds. Proton determines element. Electron guides bonds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. On through this whole table. 1 proton, 2 protons, 3, 4, 5, 6. Carbon has 6 protons. If it has 6 protons, it has to be carbon. Doesn't matter how many neutrons, doesn't matter how many electrons. 6 protons makes it carbon. That's it. Focus on the proton first. Then, how many electrons? Because if it's got 6 pluses, then you need 6 negatives to make it balanced. If it's not balanced, it's an ion. Ion just means charged. It doesn't mean it's a weird type of carbon. It just means it's like static electricity. It's going to shock you. It could attract another electron or it could repel another electron depending on which way it was charged. Did you add an electron to the atom or did you take one away? They will all want to do different things depending on where they're at in this chart and how full their outer layers are. That's chemistry class. That's not what we're going to focus on right now. Okay? We are just going to focus on the elements and the fact that the electrons guide the bonding. Okay. Now, there are different types of bondings. We may come back to that, but what we're going to talk about now are minerals. Finally, minerals. Here we go. In the official voice. A mineral is a naturally occurring inorganic solid with orderly crystalline structure and definite chemical composition. What? What does that mean? Like, we've really got to look through all the parts of that. All right, so here we go. Hey, here are some different minerals. These are really pretty ones. That's why they made the poster or whatever. Here, you've got quartz, you've got calcite. Those are very, very common. The rest of these probably, no, there's a different type of quartz, right? These are just different minerals. Natural, first thing, it's a naturally occurring thing, meaning it has to be from geologic processes. You can't make a synthetic ruby or a synthetic diamond in a lab. That's not a mineral. Just by definition. Those are synthetic gemstones. Okay? Mineral has a definition. Element has a definition. Compound has a definition. Rock has a... Be careful. Gemstone is sometimes a broad category. There's a definition, and then there's the way people commonly use it. And those aren't always the same. Okay? So a mineral is naturally occurring. 1. 2, it's got to be solid. That's easy. In normal temperatures around Earth, is it a solid, liquid, or gas? If it's a solid, it can be a mineral. Or minerals have to be the solids. Orderly crystalline structure. Okay, you can actually see crystals. What does a crystal mean? Crystal just means a patterned solid where the atoms inside repeat, because a mineral is not an element. Elements were the periodic table. There's one thing. Gold, silver, those are natural, those are minerals, but they're the rare exception. Most minerals are multiple elements from the periodic table. So, halite, here you go. Halites right here, looked up. Ooh, there's all these pretty halites. Looks like a crystal. It's always going to have nice straight edges in different spots. It's always going to have these. It's orderly. And you may look at that and say, well, they're jagged edges. They're jagged edges, but if you zoomed in to like the microscopic to the atomic level, it's going to be a straight line in one spot. And there may be, when it hits a corner, it may do weird things, but it's going to be super even and super uniform because it's a crystal and it's going to repeat. Sodium, chlorine, sodium, chlorine, sodium, chlorine, sodium, chlorine. Over and over and over. It's going to have a structure. That's what a crystal is. All right. So atoms of the ions are in a form and they repeat. They're repetitive, the order they're at. Okay. All right. Let's see. Definite chemical composition. All right. Let's look at these. These are more minerals. Definite chemical composition. Well, meaning we know what it's made of, right? Quartz is silicon dioxide, SiO2. So one silicon and two oxygens all stuck together. That's quartz. And we know what it is, and it's the same, and it's always going to be the same. Most minerals are compounds. I already said silver and gold are kind of exceptions. All right. Other things, it's organic. So I gave this long list of things that minerals are. I said it wrong. Minerals are inorganic. They're not organic. Okay, organic comes from living things. Organic has lots of carbon. You can have carbon, but you just can't be like based off a living thing. So think of this. Sugar, crystalline sugar is a crystal. It's a solid. Why isn't it a mineral? Because it comes from sugar cane or beets or somewhere else, and that makes it organic. It was formed by a living thing. It wasn't formed by geologic processes. So salt, crystalline white solid, and sugar, crystalline white solid. Salt's a mineral, halene. Sugar is not. Wait a minute, salt's halene, halite. These that I showed you earlier, halite, yeah, that's all salt. That's plain old table salt. All right, there's some impurities that turn it different colors, but it is a very natural, mineable mineral. All right. Last thing, it's got to be formed by geologic processes. That's it. So now we know those are the things that a mineral does. Last thing for today, I'm just going to list what are those processes, what are the common processes and ways to make minerals. Crystallization from magma. What? Deep, deep in the earth. It's hot. Everything's molten and melted. And then the volcano erupts and magma flows down the side. As that lava cools, the magma comes above surface, now it's lava. And as it cools, some elements, some minerals start to crystallize, solidify out. So when they crystallize from magma, that's one way to make minerals. Precipitation is the second one. Not precipitation falling rain, but the one, it does deal with water. If I take salty water and then I evaporate it and then the stuff that's left around is a mineral. Whether it's pure salt or something else, there's anything that was dissolved in the water will be left when the water evaporates. That's a mineral. You can have changes in temperature and pressure. That's a really broad category. That can happen deep in the earth with changes in pressure and temperature, and they can create minerals. The last one's the exotic one, hydrothermal solutions. Hydrothermal solutions. Deep, deep down in the ocean, at the bottom, you've got these huge hot vents and this weird salty water and the stuff that's spewing out and the salty water right there, and they all mix, and then there's a chemical form. You can get weird stuff there. Or if you've ever been to Yellowstone, and if you haven't, throw that somewhere on a bucket list. It is a great trip. It's a long way. It's a great trip. All right. Those are hydrothermal vents that are above ground, like those sulfur pool. You see weird colors at all those geysers. Those you can get crystals at because those are hydrothermal spots. And depending on the minerals that are available, not crystals, I said crystals, minerals. You can get minerals at there. All right. It's a good day. We're back from Earth. Astronomy's over. Make sure you guys are keeping up with your work. We're going to get some assignments, and we're going to start classifying minerals and rocks next time. All right, everybody, you guys have a great day.